This is a presentation on chemistry that changed the world. The topic I have chosen for this presentation is mustard gas, a chemical most commonly known for its use during World War I in chemical attacks on soldiers. Mustard refers to a class of chemical weapons that are toxic to living cells and tend to cause blistering. The compound commonly known as mustard gas, sulfur mustard, was first discovered by Caesar Desprets in December of 1822. He described the compound as having a bad smell, but none of the toxic properties we know it to have. Albert Niemann was the first person to describe these properties. He followed the work of Desprets and described his product as having a terrible smell, but also causing skin to redden and blister several hours after it comes into contact with the compound. By World War I, the Germans had created a process for the mass production of mustard gas, which was based on the Meyer-Clark method, which used ethylene chlorohydrin as a reactant which Germany had in large quantities because of the large dye industry at the time. The method used by Desprets in 1822 reacted ethylene with sulfur chloride together to produce sulfur mustard. However, Niemann was aware that sulfur chloride was unstable and volatile and therefore difficult to use. Meyer used a chlorination reaction to produce sulfur mustard. He reacted thiodiglycol with phosphorus trichloride, which substitutes the OH groups for chlorine atoms. This was refined to use hydrochloric acid instead of phosphorus trichloride, as this produces water as a second product, while still making sulfur mustard and is therefore safer. Mustard gas is a blistering agent, meaning that once it comes into contact with a person, it will damage the skin. It is also an alkylating agent, meaning that it can destroy cells, DNA, and even liquefy tissue. Exposure to mustard gas mainly has effects on the eyes, skin, respiratory system, and digestive system. These effects include irritation, inflammation, blisters, shortness of breath, nausea, and in some cases blindness. Prolonged exposure to mustard gas is fatal. During World War I, the use of mustard gas led to the creation of the gas mask. An early example is the British Hypo helmet, which was a cloth mask that was dipped into anti-gas chemicals such as sodium hyposulfite and glycerine. However, this mask was ineffective, as the eyepiece of the mask was easy to break, meaning that the mask was useless. However, this mask did boost morale for the soldiers, as it was a sign that a solution to the gas problem was being worked on. By January 1917, a new, more sophisticated mask was made standard issue for British soldiers. The small box respirator more closely resembles the modern gas mask and reduced the number of deaths caused by gas. As previously stated, mustard gas is an alkylating agent, so it can destroy cells. Two doctors from Yale University, Louis Goodman and Alfred Gilman, noticed a low number of immune cells in the blood of soldiers affected by mustard gas. The hypothesis that they came up with from this was that if normal white blood cells were killed by mustard gas, then cancerous white blood cells would also be killed. It was found that nitrogen mustard reduced the size of tumors when injected into the body, and prolonged treatment helped provide comfort to those with large tumors, as each treatment reduced the size. This discovery started what we know today as chemotherapy. This concludes my presentation on mustard gas and chemistry that changed the world.